Hello good people. A lot of passionate mathematics can be achieved with raw numbers alone. But to achieve all the shivering joy that mathematics offers, we also need a few symbols and operations. Many of these will be familiar to you. We have the equality sign, which is telling us that whatever is on the left-hand side equals whatever is on the right-hand side. Should we have a case where that is not true, we use the inequality sign. There are instances where we want to compare the left to the right-hand side in terms of size. This is where we use the greater and less than signs. Note that these signs can be read from left to right and from right to left. I could say that 11 is greater than 3 or 3 is less than 11. In the second example, I could say that 6 is less than 41 or 41 is greater than 6. So how do you remember which one indicates greater than and which one indicates less than? One way to remember it is to think of this sign as a mouth of a crocodile. Let me draw in some teeth. The crocodile always wants to eat the greater amount of fish. So the mouth is always open toward the side that is greater. Let's get reacquainted with a few mathematical operations. Note that when it comes to the symbols for multiplication, we have a couple of options. We can use the traditional X, a dot, or an asterisk. In case of division, there are two common symbols. We have the obolus, which is this line with a dot above and a dot below, and then we have the forward slash. The truth is that most mathematicians and scientists will avoid both of these symbols like a suspicious chocolate bar in a swimming pool. We prefer to use fractions when it comes to division, but more on that horror later. For now, let me quickly explore a few examples of these four mathematical operations. For an addition, we have 12 plus 17, that gives us 19. In case of a subtraction, we have 11 minus 6, and that gives us 5. In case of a multiplication, we have 4 multiplied by 3, giving us 12. Note that a multiplication is a shorthand for repeated additions. 4 multiplied by 3 can also be expressed as 3/4 being added together. Alternatively, we have 4 3s that are being added together. What is hiding behind a humble division? Here we have 15 divided by 3 gives us 5. A division is a shorthand for repeated subtractions until we reach 0. In other words, how many times do I have to subtract 3 from 15 to end up with 0? There are a few more things that I would like to briefly explore. In mathematics, we really enjoy brackets. We can have the usual curved brackets, also known as parentheses, the square brackets, and the curly brackets, which are sometimes referred to as braces. While in different science disciplines these types of brackets might serve different purposes, in mathematics they're asking us to deal with what's in the bracket first. If we have 17 minus in brackets 30 divided by 2, we need to solve the bracket first. 30 divided by 2 is 15, and so we will have 17 minus 15, and that would give us 2. We're almost there. There are two more things I want to cover: powers and radicals. When it comes to powers, we will have some number n that is being raised to some power p. In my case, the number is 4 and the power is 3. What is hiding behind this 4 raised to the power of 3? It is a repeated multiplication. 4 to the power of 3 is telling us to take 3 4s and multiply them together, and that will give us 64. On your calculator, that might look something like this. Enter the number first, and then to raise it to the power of 3, I'm going to press this to the power of button, which is x with a white blank square, and now I can enter the power, in this case 3, and when I press equal, I get the result. What about the root or radical symbol? If I have a root or a radical of 16, it is in fact the second or the square root of the 16. And so I could rewrite the radical symbol with a little 2 up here at the top. Please note that if we do not place a 2, we are assuming that it is there. So a radical symbol on its own is the same as the second radical, which is the same as the square root. The radical symbol is asking us a question. Which number multiplied by itself will get me to 16. If you know your multiplication table, the answer is 4. However, you can also use your calculator. To determine the square root or the radical value of any number, I enter the radical symbol first, and then beneath the radical symbol, I enter the value that I'm interested in. When I press equal, I get the result. Please note that not all roots are square roots. Here we have the third root, or the third radical of 125. This is asking us which number raised to the power of 3 will get me to 125. If I wish to enter any radical, I press the Shift button and then the X with a blank square button. Now, in the upper corner, I will enter the radical, and then below the radical symbol, I will enter the value. Powers and roots are linked. I can use one to check the other. So in this case, I can enter 5 raised to the power of 3, and I'm hoping to get 125, which is what indeed happens. In the last example, we have the fourth root, or the fourth radical, of 10,000. In other words, which number raised to the power of 4 will get us to 10,000. Again, I'm going to use my calculator. I'm going to enter Shift and then the X with a blank square. Now I can enter any radical, in this case 4, and beneath the radical symbol I will enter 10,000. When I press equal, I get 10 as a result. We are going to explore powers and radicals some more later on. Something to look forward to. That is all for now, and I will see you on the flip side.